Hello students, welcome to grade 12 chemistry revision lesson on chemical kinetics. At the end of this lesson, you will be able to explain the factor that affect the rate of reaction, express reaction rate in terms of the disappearance of the reactants and the appearance of the products, explain what is meant by reaction rates and perform activities that determine it. Chemical kinetics. Chemical kinetics answer the question, how fast does a reaction proceed? Therefore, reaction speed measured by the change in concentration with time. Rate of reaction is the change in concentration of a reactant or a product over a given period of time. Now for this simple reaction A to product or A to B, the rate of reaction is expressed in terms of reactant and in terms of product as rate equal minus change in concentration of A divided by change in time equal in terms of product is change in concentration of B or product divided by change in time. Students, why do we introduce a negative sign here? Because change in concentration of M is final M. Rate equal change in concentration of M is final concentration of M. A final minus A initial M initial divided by change in time is T final minus T initial. You see, the final concentration is less than the initial concentration because reactants are converted into products. Now, A final minus A initial is negative, but rates cannot be negative. In order to make it positive, we introduce a negative sign here. Therefore, when rate is expressed in terms of concentration of a reactant, a negative sign is used. Now, rate equal minus change in concentration of A divided by change in time equal, in terms of product, is change in concentration of product divided by change in time. Reaction rates and stoichiometry. In general, for the reaction A plus B to form C plus D, where A, B, C, and D are stoichiometric coefficients, the rate of the reaction is given by, in terms of reactant, rates equal minus 1 over M. Change in concentration of A divided by change in time equal minus 1 over B. Change in concentration of B divided by change in time equal, in terms of product, 1 over C change in concentration of C divided by change in time equal 1 over D change in concentration of D divided by change in time. For example, if the rate of formation of ammonia, rate of appearance of ammonia for this reaction is 0.345 molar per second. The unit of rate is molar per second because rate by definition, rate is change in concentration of the reactant divided by change in time. Concentration is expressed in molarity, molar. Time in second, molar per second is the unit of rate. What is the rate of disappearance of nitrogen? Now, rate of disappearance of nitrogen is minus change in concentration of N2 divided by change in time equal 1 over 2 times change in concentration of NH3 divided by change in time. Now the rate of disappearance of nitrogen equal half times rate of appearance of ammonium is 0.345 molar per second. 0.345 molar per second. Molar per second. Now this is half times 0.345 is 0.173 molar per second. This is rate of disappearance of nitrogen. Example 2, Write the rate expressions for the following reactions in terms of disappearance of the reactants and the appearance of the products. M I minus plus OCl minus Cl minus plus OI minus. Now, rate of this reaction in terms of reactants and in terms of product is written as for M rates equal minus change in concentration of I minus divided by change in time equal minus change in concentration of OCl minus divided by change in time equal, in terms of product is plus change in concentration of Cl minus divided by change in time equal change in concentration of OI minus divided by change in time. This is rate of a reaction in terms of disappearance of a reactant and in terms of appearance of a product. B rates equal in terms of disappearance of a reactant is minus 1 over 3 change in concentration of O2 divided by change in time equal 1 over 2 times change in concentration of O3 divided by change in time. C rates equal terms of reactant is minus 1 over 4 change in concentration of ammonia divided by change in time equal minus 1 over 5 change in concentration of O2 divided by change in time equal 1 over 4 change in concentration of NO divided by change in time equal 1 over 6 change in concentration of water divided by change in time. This is rates for this reaction in terms of disappearance of the reactant and in terms of appearance of the product. Students, let us try this exercise so that you can practice what we have just learned. You have 3 minutes. Welcome back again, students. How did you do it? Good. Let us do together. 1. For the reaction 2NOCl gas, 2NO gas plus Cl2 gas, M. Express the rate of reaction in terms of concentration of NOCl. Rates of the reaction in terms of concentration of NOCl. Rates equal minus 1/2 change in concentration of NOCl divided by change in time. This is rates of this reaction in terms of disappearance of NOCl. B relates the rate of reaction of NOCl with the rate of reaction of NO and Cl2. Rates equal minus 1/2 change in concentration of NOCl divided by change in time equal 1/2 change in concentration of NO divided by change in time equal change in concentration of Cl2 divided by change in time. Here it says relates the rate of the reaction of NOCl. Now the rate of the reaction in terms of NOCl is this, therefore minus change in concentration of NOCl divided by change in time equal multiplying both sides by 2 gives change in concentration of NO divided by change in time equal 2 times change in concentration of Cl2 divided by change in time. Number 2, the reaction for the formation of ammonia is given as N2 gas plus CH2 gas to form 2NH3 gas. Write the rate of the reaction for the formation of ammonia. Rates equal 1/2 change in concentration of NH3 divided by change in time. B, the disappearance of N2 and H2. Rates equal minus change in concentration of N2 divided by change in time equal minus 1/3 change in concentration of hydrogen divided by change in time. Factors influencing the reaction rates. Students, what factors affect the rate of the reaction? Good. These are the factors which affect rate of the reaction. 1, change in temperature. As you know, an increase in temperature increase rate of the reaction, because when temperature increase, the reacting particles, reactants, more collide frequently with greater energy. An increase in temperature increase the average kinetic energy of reacting particles. Therefore, an increase in temperature increase rate of the reaction. 2, concentration. We know that rates of the reaction is directly proportional to concentration of the reactant. When concentration of a reactant increase, rate of the reaction increase, because more reacting particles can collide, can contact. 3, nature of the reactant. This is chemical behavior of reacting particle, reacting substance. You can take this as an example: magnesium plus hydrochloric acid to form magnesium chloride plus liberation of hydrogen gas H2. Again, zinc plus hydrochloric acid HCl to form zinc chloride plus hydrogen gas is liberated. Copper plus hydrochloric acid, copper plus HCl, no reaction. You see? Now this is chemical behavior of reacting substance. You see? Magnesium is more reactive than zinc. Therefore, this reaction is fast reaction, you see, is fast. Zinc is less reactive than magnesium. Now this reaction is slow. Copper can't displace hydrogen from a substance. No reaction. Therefore, nature of the reactant. Now this is chemical behavior of reacting substance. Surface area or states of subdivision. Now this is important for heterogeneous reaction. In general, when surface area of reacting substance increase, rate of the reaction increase. If you take the reaction between hydrochloric acid and chalk, you see, calcium carbonate, now this is powdered chalk plus hydrochloric acid and calcium carbonate, this is cube chalk plus hydrochloric acid. Now compare rate of the reaction for these two reactions. Which is more fast? Calcium carbonate powdered plus hydrochloric acid is the fast reaction because more calcium carbonate powdered can contact with hydrochloric acid. As surface area of reacting particle increase, rate of the reaction also increase. Is fast reaction than this. The other factor which affects rate of the reaction is availability of a catalyst. As you know, a catalyst increase rate of the reaction by lowering activation energy of the reaction. Catalysts are of two types, positive catalyst and negative catalyst. Positive catalyst increase rate of the reaction by lowering activation energy of the reaction. Negative catalysts are known as inhibitors, which decrease rate of the reaction by increasing activation energy of the reaction. These are factors which affect rate of the reaction. Theories of reaction rates. The two important theories of reaction rates which helps us to understand rate of the reaction are collision theory and transition state theory. Now, the rate of reaction is directly proportional to the number of collisions per second or the frequency of collision. According to collision theory, in order for the reaction to take place, there must be collision between reacting substance, reacting particles. Therefore, rates of the reaction is directly proportional to number of collisions per second, or rate of the reaction is directly proportional to frequency of collision. Number of collision per second is frequency of collision. More collision between reacting substance, the rate of the reaction is high. According to collision theory, a reaction to occur between reactants, one, the particles of the reacting substance must collide. For a reaction to take place, there must be collision between reacting species. Note that all collisions do not result in the formation of reaction because collisions are of two types, effective collision and ineffective collision. Effective collision is collision between reacting substance which results in the formation of reaction and form desired product. The other type of collision is ineffective collision which do not result in the formation of a reaction. Two, the particles of the reactants must collide with energy greater than or equals to energy of activation. Colliding species must have enough energy to form a product. The minimum amount of energy required to start a reaction is activation energy. If energy of colliding substance is less than activation energy, no reaction takes place. The third postulates of collision theory is the particles of the reacting species must have proper orientation. Colliding species having enough energy must be oriented properly. If reacting particles, reacting species have no proper orientation, then there is no reaction between them. These are postulates of collision theory. Rate equation or Rate's law. The overall concentration dependence of reaction rate is given in rate law or Rate's expression. Rate law or rate constants and others are determined experimentally. Order of reaction and rate constants. For a simple reaction, A2 product rate is directly proportional to concentration of A raised to X, or rate equal. This proportionality constant is rate constant K times concentration of A raised to X, where X is determined experimentally. For the general reaction AA plus BB to form CC plus DD, the rate law or rate equation for this reaction is written as rate equal K times concentration of A raised to X times concentration of B raised to Y. Order of reaction with respect to M is X. Order of reaction with respect to B is Y. Overall order of this reaction is X plus Y. X and Y are obtained experimentally. Example, fluorine combines with chlorine dioxide as follow: F2 plus 2ClO2 to form 2FClO2. This is initial concentration of F2, initial concentration of ClO2, initial rate. Prove that rate of this reaction is K times concentration of F2 times concentration of Cl2, where K is 1.2 molar per second. Prove rate of this reaction is this, when initial concentration of the reactants are this. This is initial rate method. What did you? Rates for this reaction are rates equal K times concentration of F2 to the power X times concentration of ClO2 to the power Y. X and Y are determined experimentally. Now, to get the value of X, vary concentration of F2 while keeping concentration of ClO2 constant. Therefore, when concentration of F2 vary, you see, you can take rate 1 and 3, R1 over R3 equal 1 over 2 to the power of X, 1 over 2 raised to X. Concentration of ClO2 is constant, equal 12 over 24, equal 12 over 24. Now this is the same as 1 over 2 raised to X equal 12 over 24 is also 1 over 2. From this, X equal 1. To get the value of Y, vary concentration of ClO2 while keeping concentration of F2 constant. If you take rate 1 and rate 2, R1 over R2, R1 divided by R2 equal 1 over 4. 1 over 4 to the power Y, equal rate 1 over rate 2 is 12 divided by 48. 12 divided by 48. Now this is the same as 1 over 4 to the power of Y equal by 12 is 1, by 12 is 4. Again from this, Y equal 1. You see, Y equal 1. Rate law for this reaction is rate equal K times concentration of F2 to the power of X times concentration of ClO2 to the power of Y. X is 1, Y is 1. Therefore, rate of this reaction is K times concentration of F2 times concentration of ClO2. What is the rate law for this reaction? Now, the rate law for this reaction is R equal K times k times concentration of m to the power x times concentration of b to the power y times concentration of c to the power z, where x, y, and z are obtained experimentally. Now, to get the value of x, vary concentration of m while keeping concentration of b and c constant. You see. Concentration of B, R1, R2 constant, rate 1, rate 2, experiment 1, experiment 2, constant. Now, 0.273, 0.273 divided by 0.819 to the power x equal, rate 1 divided by rate 2 is 3 over 9, you see. By 3, this is by 0.273 is 1 over 3 to the power of x equal, this is 1 over 3. From this, x equal 1. The value of x is 1. To get the value of y, vary concentration of B while keeping concentration of A and C constants. Now, concentration of A is constant. In experiment 1 and experiment 3, concentration of C is constant. Therefore, 0.76 divided by 1.526 to the power y equal, R1 divided by R3 is 3 over 12, which is by 0.763, this is 1 over 2 to the power y equal 3 over 12 is 1 over 4, 2 over 1 over 2 to the power 2. From this, y equal 2. The value of y is 2. To get the value of z, vary concentration of C while keeping concentration of A and B constants. Now, experiment 1 and 4. Concentration of C vary, you see, 4 over 8 to the power z equal rate 1 and rate 4, 3 over 6. By 4, 1 over 2 to the power of z equal, by 3, 1 over 2. From this, z equal 1. The value of z is 1. Therefore, rate of this reaction is R equal K times concentration of M to the power of X, the value of X is 1, times concentration of B to the power Y, the value of Y is 2, times concentration of Z, concentration of C to the power Z, the value of Z is 1. Now this is the rate law for this reaction. Rate equal K times concentration of A times concentration of B to the power of 2 times concentration of C. Temperature and collision theory. Svante Arrhenius developed a mathematical relationship between rate constant, activation energy, and temperature of the reaction. Now, according to Svante Arrhenius, K is rate constant, equal M. M is frequency factor A times e raised to minus EM. This is activation energy divided by R is universal gas constant times temperature of the reaction. Now multiplying both sides by natural logarithm, this becomes ln K equal ln M minus EA divided by RT, EM divided by RT. We can write this as ln K equal minus EA divided by R times 1 over T plus ln M. This equation is similar to equation of a straight line, which is y equal mx plus b, where M is slope of the line and B is the y-intercept. Therefore, a plot of length K versus 1 over t is a straight line with slope minus EA divided by R. What do you understand from this equation? This equation shows that for a reaction having large value of activation energy, its rate constant is small and the reaction is slow. When temperature of the reaction increase, the rate constant also increase and the reaction is fast. This is the relation between rate constant and temperature. For two different temperatures, T1 and T2, and K1 and K2 for the same reaction, log K2 divided by K1 equal minus A divided by 2.303 into 1 over T1 minus 1 over T2 plus log A. Example, the rate constant at 327 degrees centigrade is 2.7 times 10 raised to minus 4 per molar per second. What is the temperature at which the rate constant increase to 3.2 times 10 to the power of minus 2 per molar per second? Activation energy of this reaction is 166.7 kilojoule per mole. Yes. For two different temperatures, we have two rate constants, K1 and K2. Therefore, log number 1, log K2 divided by K1 equal activation energy EM divided by 2.303 R. R is universal gas constant having value 8.314 joule per Kelvin into 1 over T1 minus 1 over temperature T. 1 over temperature T. Now what is given? Temperature 1, T1, temperature 1 equal 327 plus in Kelvin 273 equal 7 stream 10 27 9 10 32 5 6 600 Kelvin. K1 equal 2.7 times 10 raised to minus 4 per molar per second. What is the temperature? You are asked to calculate temperature to T2 is unknown. K2 equal 3.2 times 10 to the power of minus 2 per molar per second. Activation energy EM is 166.7 kilojoule per mole. Substituting this value in this equation and solving for T2, we get 425 degrees centigrade. Temperature is 425 degrees centigrade. Number 2, given the activation energy for the hydrolysis of sucrose, which is 108 kilojoule per mole. Compare the rate constant for this reaction at 37 degrees centigrade with the rate constant of the same reaction at 27 degrees centigrade. Again, substituting the given value in this equation, we get K1 divided by K2 equal 4. Now the reaction at 37 degrees centigrade is about 4 times faster than at 27 degrees centigrade. 3. The activation energy of a first order reaction is this. Activation energy is given at 25 degrees centigrade. At what temperature will the rate constant double? At what temperature? K2 become 2 times K1. 2 times K1. Again, substituting the given value in the formula, in the equation, you get T2, 308 Kelvin. From this, what do you understand? A 10 degrees centigrade change of temperature doubles the rate. Doubles the rate. Students, in our today's lesson, we learned rate of reaction. Rate of reaction is the change in concentration of reactants or a product over a given period of time. Factors influencing the reaction rates, factors such as temperature, concentration, surface area, catalyst, and so on are factors which affect rate of the reaction. We learned theories of reaction rates, the two important theories which help us to understand rate of the reaction are collision theory and transition state theory. According to collision theory, for a reaction to take place, there must be collision between reacting species. We learned temperature dependence of Arrhenius equation. This brings us to the end of our today's lesson. Until next time, goodbye.